Today's topic is going to be bonding. We'll begin with looking at the periodic table of the elements. Let's remember that over here on the left side we have our metals, as depicted in blue here, and over to the right we have nonmetals. Let's remember that every element is made of the same atom type, and the atoms are made of neutrons and protons in the center, and electrons orbiting in the electron cloud outside the nucleus. So as we look at the metals on the periodic table of the elements, we can say that usually they will lose electrons, and nonmetals over here, they tend to gain electrons. That's kind of where our starting point is today. So why would an atom lose electrons? We know that in an atom that we have equal number of protons and electrons. So for every plus we have a minus. And at the end of all the adding and subtracting, we end up with 0. If you have just as many positives as you do negatives, then the ultimate charge will be 0. And that's what we have in an atom. So why would they lose electrons? Or why would they gain electrons? Well, their desire is to have an outer shell that is full. And remember, we learned that 8 makes them very happy, except for hydrogen and helium, and 2 is enough to fill their first shell up. So other than that, usually atoms would like 8. Well, we're looking at sodium here, and sodium has 1 outer shell electron, and remember we call the outer shell electrons valence electrons. And if we look over here beside sodium, this would be magnesium, and it would have 2 valence electrons. And remember, sodium and magnesium both actually would desire to have 8. And for sodium to have 1, it would need 7 to fill that outer shell up, and that would take a tremendous amount of energy to do that. So given that, it's easier for sodium to give that 1 electron away, making this its outer shell, now having a full outer shell. But the thing is, protons and electrons are no longer equal. They have 1 more proton than they do electron when this happens, and this gives an overall charge of a +1. So now we don't have a sodium atom anymore. Once the electron is given, we actually have a sodium ion. And the same for magnesium over here. If it gives 2 of these electrons away, then the second shell would be its outer shell, and it would be full. So magnesium would be very stable then, very happy, but it would be lacking 2 electrons. And so there's 2 more positives than negative, giving it an overall +2 charge. So now if it has a plus charge, or on this particular case would have a plus charge, it's now an ion and not an atom. So why would an atom gain electrons? Well, if we look over here to the left, this has 7 valence electrons, or 7 electrons in its outer shell. So it would only need 1. This is chlorine. It would only need 1 to be full, and it's much less energy involved in just taking that 1 rather than losing all of these other 7. And over here, this one, well, it would only require 2. So if there's only 2 that's needed here, then it would stand to say that it would also be more beneficial to gain 2 than to give away the 6. So what happens when they're gained or lost? I've kind of already talked about this. Here we have 3 protons and 4 electrons, so you have 4 negative charges and 3 positive charges, given an overall charge of -1. And over here to the right you have 3 protons and 2 electrons, and giving this one 2 negatives, 3 positives, giving it a charge of +1. So basically, atoms will gain and lose electrons in an effort to fill up their outer shell, but at that point they're no longer called an atom, they're called an ion because they have a positive or a negative charge. So here is sodium, which we've already looked at, and chlorine, which we've also already looked at. Sodium will very freely give up this 1 electron, giving it a +1 charge. It's getting rid of a negative, so it becomes positive. And chlorine gains that negative charge, so now it has more negatives than positive, so it becomes -1. So you have a negative and a positive, and opposites attract. So what we have formed here is an ionic bond. An ionic bond will be between a metal and a nonmetal, and there's a loss and a gain of electrons, creating a positive and a negative charge, and these two form a bond due to it. That's an ionic bond. Another example here would be magnesium and oxygen. We looked at both of these on the previous slides. Magnesium is only holding 2 valence electrons, while oxygen has 6. So that magnesium is very willing to give up those 2 electrons, giving it a +2 charge, giving up 2 negatives, and oxygen, gaining those 2 negatives, will become 2 minus. And here again, that's another example of an ionic bond. Now, as I've said, ionic bonds are formed between metals and nonmetals. But what happens when 2 nonmetals bond? Well, we call that a covalent bond. Nonmetals are not going to give and take the electrons. They're actually going to share them. So when you have 2 nonmetals come together, they're going to share electrons, and we call that a covalent bond. And you can look here, carbon, which would normally have 4 valence electrons, is bonding up with hydrogen here, which only has 1 valence electron, but remember I said it takes 2 to make hydrogen full. So you have carbon sharing 1 with hydrogen 4 different times, and hydrogen sharing that 1 with carbon. So each hydrogen will have 2 valence electrons, and the carbon will ultimately end up with 8 by sharing. And over here to the right we have water, which is a covalent bond. Remember, oxygen has 6 valence electrons, and 2 hydrogens will readily hook up to that to share their 1 outer shell electron. That gives oxygen the 8 it desires, and hydrogen the 2 that it desires.